Good afternoon, I'm Brad McCoy. I'm going to be talking about the rapid restoration of bridges using bolted composite plates. Raise your hand if you've ever driven across a bridge like the one you see here, with a sign like the one you see here. Well, if you're like me, you probably didn't pay attention to the sign. It's likely the sign didn't pertain to you anyway. However, if you're driving a large vehicle, this sign could be a warning that the bridge is unsafe. In North Carolina, these weight limits can add an average of 45 minutes to a round-trip bus ride for some of our school children. Damage to pre-stressed concrete bridges, like the damage you see here on the left, occurs over time as the concrete corrodes and exposes the steel. Now, this deterioration occurs more rapidly in corrosive environments, such as agricultural or coastal regions. As the concrete corrodes, the steel is exposed, and the bridge can no longer carry the load it was intended to, and these limits must be posted to ensure public safety. My research is the development of a retrofit solution using bolted composite plates, shown here attached to the bridge beam on the right. My innovative research applies bolted composite plates to deteriorated pre-stressed concrete bridges rapidly, to restore the losses so the bridge can carry the load the deteriorated concrete and steel cannot. The retrofit has a lifespan of 3 to 5 years, extending the useful life of the bridge, giving transportation officials time to schedule, budget, and construct a permanent bridge replacement. Through my research, bolt size and spacing are designed to optimize the capacity of the plate and increase ductility of the system. My research also includes installation optimization such that a maintenance crew with common tools can install the retrofit in just 1 day. During the installation process, the composite plate is pulled in tension to more than 18,000 pounds of force. This tensioning process is a unique innovation for bolted composite plates and is critical to restore the load capacity and meet code requirements such that the weight limits can be removed. The current solution available to transportation officials is to simply post these limits. Why not just continue to do that? Why is my research important? Well, these posted load limits mean detours for restricted vehicles. If your child is riding that detoured bus, you're certainly interested. If there's a detour between you and the local fire station, it means an average response time of 14 minutes instead of just 5. Further, these detours cost local industry $10,000 per day per bridge in operating costs. My innovative retrofit solution using bolted composite plates can be installed rapidly to restore deteriorated bridges' original load-carrying capacity, extending the useful life of our aging infrastructure and decreasing travel costs while not compromising public safety. Thank you.
Hi, good afternoon. My name is Francisco. I'll be presenting to you the micromechanical properties of pure cement faces under the effects of different magnesium sulfate concentrations. A lot more entertaining than that. By the end of my talk, 55,000 tons of concrete will be produced around the world. That is equivalent of 250 Statues of Liberty put together. In this time, 2,500 tons of cement were already produced, equaling around 1,000 pickup trucks. So you can have an idea of the massive amounts that we use of this material. What is concrete, you may be wondering? Well, concrete is a mixture of cement, sand, rocks, and water. If you take a look at the amount of water used to produce concrete, and a staggering 2.5 billion cubic yards were used in 2018 alone. Let me put that into perspective. That is the amount of water falling down the Niagara Falls for 9 days straight. And it is water that you and I could be drinking right now. By 2050, it is expected that 3/4 of the water needed for concrete production will likely happen in water stress areas, posing a dangerous cost-benefit trade-off in developing regions. So what is the solution? Well, given the fact that 40% of us live within 60 miles of the coast, that is around 3 billion people, why don't we take non-drinkable water, such as seawater, in the production of concrete? Now, certain salts present in seawater may cause damage to concrete. In other words, if I take seawater and I mix it with cement, will I see any degradation on the mechanical properties of concrete itself? In order to answer these questions, I have developed a method to synthesize the basic building blocks of concrete. Then I have exposed them to seawater and test their mechanical properties at a nanoscale level using a method called nanoindentation. Nanoindentation can be pictured with your finger. If you poke glass or jelly, you're going to have an idea of the properties of these very different materials. The same thing here applies, but at a nanoscale. Let's think about that. A nanometer is to a tennis ball what a tennis ball is to Earth. So we are considering a very small scale. The reason we're doing so is because it allows us to simulate the surface life of a concrete member exposed to seawater for 100 years or more in just a couple of weeks, saving a lot of testing time. So far, our findings suggest that a loss of 15% in strength is expected from the use of seawater. With this understanding, we can use this information and compensate this loss in our mix design, so therefore it's no longer a problem. In these short 3 minutes that I've been talking to you, 300,000 families in Africa could have saved the equivalent of 2 days of water if we use seawater as a replacement for concrete production. Thank you.
Good afternoon, everyone. My name is Ishtiaq Ahmed, and the title of my presentation is Lane Change Analysis to Improve Freeway Operation. Imagine you are driving on a busy road. Suddenly, you need to change lane to merge with traffic or to pass a slow vehicle. Even if you don't see large enough gaps, you may end up changing lanes by slowing down other vehicles. Some drivers also change lanes more than they have to. Abrupt and excess lane changes like this are not only risky, but also create turbulence, dropping the speed of traffic and triggering traffic jams. When we are living in a country where traffic congestion costs more than $300 billion per year, dear audience, why don't we improve the operation of our roads by managing lane changes and providing proper guidance about it? In addition to traditional techniques like road signs and lane markings, the increasing number of self-driving vehicles can help implement a lane guidance system to reduce abrupt and excess lane changes. To do so, the very first task is to detect lane changes and then characterize those by their position, time, and other dynamic characteristics. In my dissertation, I am accomplishing all these tasks using a simple, low-cost, yet robust technique. To detect lane changes, I am using a GPS device that costs only $20 per unit. Through a cell phone internet connection, it transmits vehicle global position data at each second in real time. However, the major issue of using such a low-cost GPS device is that it cannot give vehicles lane position data at an acceptable accuracy. The randomness and error in the GPS data can create a lot of false alarms. To tackle this issue, I developed a series of field-verified thresholds in space and time to reduce these false alarm rates while maximizing the detection of correct lane changes. Thus, the algorithm I developed in my thesis detected more than 90% of the lane changes accurately. In this study, 40 drivers used this GPS device in their own vehicle voluntarily for more than 2 years, making thousands of trips through many busy roads in Raleigh, North Carolina. A strict privacy policy and anonymity were maintained throughout the time. I applied this lane change detection algorithm on this dataset for several critical roads. It revealed the tendency of excess lane changes, their position, time, and other dynamic characteristics. My research showed that there are significant scope of improving the capacity of these busy roads by guiding how and where to change lanes. Dear audience, as connected and autonomous vehicles are increasing in numbers, the outcome of my research will contribute even more to improve the operation of our limited road network. Transport agencies can use this tool to monitor lane changes on busy roads. Based on that, they can control and provide guidance to reduce abrupt and excess lane changes, saving people life, time, money, and energy. Thank you very much.
Shivpal, and I'll be going to talk about moisture damage in roads. So the United States of America has approximately 4 million miles of road, which makes it the world's longest road network, and out of which more than 90% of it is asphalt roads. Asphalt roads are made up of mixture of stones that are bind together by asphalt, a petroleum byproduct. So who doesn't love to drive on a new and smooth surface roads like that? But when the moisture gets inside and with the passage of traffic induces damage like cracking and potholes, which you can see in the picture here, and I'm sure nobody wants to drive on a surface like this. Moisture is one of the main reasons of these poor condition of roads. Due to the presence of moisture induce two kinds of damages, adhesive damage and cohesive damage. Adhesive damage is the separation of asphalt from stones, while cohesive damage is the damage occurring within the asphalt. So before the construction of a road, every state agency perform a standard test to check whether a mixture is good or bad for construction. But there have been numerous occasions where a mixture passes the test but performs poor in the field. So that is the problem, that the current test is not comprehensive. And here my research comes into the picture. First, we looked into why those mixtures passing the test but performing poor in the field. And we found that the existing test only accounts for the adhesive damage occurring in the material. But in field, adhesive and cohesive failure collectively causing the damage in the roads. So we developed an alternate test method that detects both adhesive damage and cohesive damage. In our lab testing, we tested 6 different asphalt mixture, and we performed both the tests, the existing test and the new test developed in this research, and the results were quite promising. The result shows that 2 of the mixture passes the existing standard test used by state agencies. That means that is good for construction. But the same material fails in the newly developed test, and the reason behind that is the existing test doesn't detect the cohesive damage in those material, while the newly developed test is able to detect both adhesive and cohesive damage. Also, the new test reduced the testing time to 1 day against a week needed for the existing test. And more importantly, this new test will save a lot of money for the government, which they spend on maintenance of those roads, and the use of good material will provide better quality of road for public. Thank you.
Hey everyone, my name is Joe Hollingsworth, and today I'm going to be presenting on a life cycle assessment of solar-powered integrated greenhouses. Have you ever thought about the environmental implications behind the food that you eat? Today in the U.S., agriculture accounts for 9% of our greenhouse gas emissions, and crops take up 15% of the land that we use. Greenhouses are a type of controlled agricultural environment that allows to thermally regulate a greenhouse, resulting in year-round crop production that can be at very high densities compared to open field systems, and also only use 1/10 of the water requirement that would otherwise be needed in an open field systems. The catch to all of these advantages is that greenhouses are inherently very energy intensive for both heating and cooling. I'm a part of a National Science Foundation research team that's studying a new type of solar panel technology called organic photovoltaics. Organic photovoltaics have many advantages, such as being lightweight, low cost to manufacture, and most importantly, they can be semi-transparent. Our research team has recognized that plants only require a small range of visible light for growth and crop productivity. Driven by this knowledge, our research team is developing these organic photovoltaics, or semi-transparent solar panels, in a manner that can transmit light that can be used for crop productivity while absorbing the light that would be needed for electricity production. My research uses life cycle assessment methodology to look at all phases of a greenhouse system. That includes materials and manufacturing for the structure of a greenhouse, use phase inputs such as energy, water, and fertilizer requirements, as well as end-of-life phase and disposal methods. My research has found that in a conventional greenhouse, 80% of our carbon footprint associated with crop production is driven directly from heating and cooling demands. However, applying these semi-transparent solar panels to the roof of a greenhouse can reduce that carbon footprint by up to 40%. This would be conserving the additional 33% of land that would be required for a typical, more common opaque solar panel device. This type of application could be used all over the world, particularly in areas that already have a lot of greenhouses, such as Almeria, Spain, that has over 75,000 acres of greenhouses in a single coastal city alone. This could even be used in more rural applications that have little access to existing infrastructure and electricity. We know that humans need food and nutrients for everyday life, and as climate becomes more uncertain, populations continue to increase, and land constraints continue to increase, we will need to produce more food in a more sustainable manner. So with that, I thank you, and I hope I've left you all with some food for thought.
Good afternoon, I am Dolraj Salise. My topic is dam effect on natural river flow. As you can see in the top left figure, dam is a structure constructed across the stream to store water behind it. Today we have more than 83,000 dams across United States. These dams are used for flood control, hydropower, irrigation, water supply, and recreational purpose. Despite many use, dams substantially damage our environment. Let's look at this picture. In the bottom left, this is the stream flow characteristics before construction of dam, whereas the right side shows the stream flow characteristic after construction of dam. We can clearly see that dam substantially reduce the stream flow. These changes in stream flow causes impact to the native fish and species that are located below the dam. So currently, reservoir manager focus on economic benefit of water and power. Unfortunately, they do not pay much attention to downstream ecosystem. In my research, I focus on two questions. The first one, what type of dams and their size impact the most? And the second one, how can we find a balance between ecosystem health and human needs? To address this question, I examined 209 dam regulated stream flow data across the United States. And here is my summary results on the right side. Here the x-axis represents different type of dams, whereas y-axis represents 32 different characteristics of stream flow. So here the red color represents the highest changes in stream flow, that is bad, and the blue color represents the least impact, that is good. So I found that hydropower dam causes highest environmental impact followed by flood control, whereas the recreational dam causes least impact. Similarly, I found that larger dam causes higher impact compared to the smaller dam. This information can be useful to reprioritize dam mitigation effort in highly regulated basins. So currently, I am developing a method which will use multiple stream flow characteristics to manage reservoir operation. This analysis can help water resources manager to manage our reservoir to meet human need for water and power while protecting long-term ecosystem health. Thank you.
So good afternoon, everyone. I will be demonstrating ways to reduce emissions of harmful pollutants from diesel trains. So how many of you here like trains? I like them because they have one of the lowest fuel use and emissions compared to other means of transport for every passenger they transport. However, do you know that emissions of harmful pollutants such as nitrogen oxides and particulate matter can be about 5 to 10 times higher compared to an average passenger car if they transport the same amount of people. So while the developed countries have adopted or are planning to adopt to more environmental friendly electric trains, US still, which has one of the largest networks of trains, is still operating most of the trains on diesel. And US has no plans to migrate to electric trains. So is that a dead end? Can we not reduce emissions from trains? No, it turns out we can. So new locomotives that have advanced emission controls can cost about like $4 to $5 million for operators, and they're not keen on buying those. And then we have some technologies that are not demonstrated for locomotives. They're mostly research theoretical models that exist to control emissions, and they're mostly lab-based tests that are not cannot be simulated in real world. So my research is focused on cost-effective measures of reducing emissions of harmful pollutants from trains and based on real-world measurement on the trains. So we did extensive set of measurements on the Piedmont Rail route between Raleigh and Charlotte. I actually compared the effect of different drivers, how do they drive, and how one driver can lead to lower emissions than others. So we found out that if we can cut down the emissions, if the drivers can accelerate or decelerate based on the track conditions that are ahead of them, they can save as much as about 20% of fuel use and emissions. Then we also investigated the effect of renewable fuels. So we tested diesel versus biodiesel. Biodiesel is a renewable fuel. it costs the same as the diesel, and it can be used in diesel engines without any modifications. So we found out that the biodiesel reduced the particulate matter emissions by 40%. It increased the fuel use and nitrogen oxide emissions, but very slightly. Then the third technique we evaluated was the emission control technology. So it costs about like a tenth of a cost of purchasing a new locomotive, and it reduced the nitrogen oxide emissions by 90%. It also increased fuel use and particulate matter emissions slightly. The combined estimates of all these three techniques together are estimated to save the Piedmont Trail operators annually about $800,000, and then 70% reduction in nitrogen oxide emissions, 30% reduction in particulate matter emissions. So these emission levels are compared to emissions from one passenger car in transporting the same number of people. And this technology can be applied to a lot of train systems in the US and developing countries. So with that, that's all.
My name is Ariadne, and today I'm going to be talking to you about the influence of earthquake hazard models on the design of reinforced concrete columns. Have you wondered how engineers design for earthquakes, which are in essence unpredictable? Raise your hand if you prefer to have a bridge look like the one on the left picture. All right, so how do we ensure that this does not happen when we do not know for certain how large the next earthquake will be or in which direction the ground will move because of it? So we actually have access to thousands of records of the vibrations of earthquakes in the past. And we have taken these historical records and translated them into predictive models that engineers use for design. There are two types of hazard models. Both account for all possible directions of the earthquake. The first one is the median hazard model, and then the maximum hazard model. Up until a few years ago, everyone was using the median hazard model. Designing for the median hazard model will always result in lesser strength structures than compared to the maximum. So you might wonder, why not use the maximum? But is designing for the worst case scenario appropriate when we're talking about earthquakes? Because you see, the worst case scenario would only happen if the structure aligns with the strongest direction of the earthquake, which is very, very unlikely. And then this poses the question of whether or not we're being cost efficient. However, building standards have moved to using the maximum hazard model without any numerical basis to support this. Because of this, our goal is to understand the implications of designing to these two hazard models, the median hazard model versus the maximum hazard model. Because this decision can mean the difference between a working bridge and catastrophic damage. So to tackle this issue, before we even start designing the bridge, we need to understand the performance of the columns. We developed computational models that allows us to compare the deformation of the columns that we designed them to have versus what actually happens during the earthquake. We did this for 35,000 bridge columns, and we subjected each of them to a series of simulated earthquake recordings. And from this simulation, we were able to obtain what the maximum deformation that they sustained during the earthquake and compare it to our initial design deformation. We learned that for bridge columns, we should use the maximum hazard model because on average, the bridge columns designed to the maximum hazard model show 5% less deformation than what we expect. In contrast, using the median hazard model shows that bridge columns sustain 20% greater deformations than what we expect. Further research is still needed to understand how these hazard models affect more complex structures, but we're now one step closer to understanding how to design for earthquakes. Thank you.
Good afternoon, I am Roshan Jadid. My topic is deformation-based stability analysis of flood-controlled earth structure. Last year, Hurricane Florence slammed into the Carolinas and caused severe damage and fatalities. Can you guess the amount of economic loss? More than $50 billion, which is almost 1% of the 1% of the federal budget of that year. One of the primary reasons of this massive loss was flooding due to the failure of earth structure like levees, dams, and embankments. To evaluate the safety of a dam, traditionally we use the factor of safety approach. But we have observed many failures that were considered as safe by the traditional approach. Now, what's the unforeseen cause of this anomaly? From my research, I have found that it is because of the gradual degradation of the dam stability with multiple flood cycle. My research offers a way to quantify this degradation and can predict real-time safety of the dam. I have used a computer model to simulate the flood condition. You may wonder how I did it. Well, during a flood event, water level rises and drops down gradually with time. I have done the same thing in my model. And in this way, the dam experiences one flood cycle and causes some permanent deformation in it. With time, with multiple flood cycle, it can accumulate and can lead to catastrophic failure. You can see an example in the slide that occurred after Hurricane Florence. And this dam survived prior floods, unfortunately failed after floods associated with Hurricane Florence. My approach can predict the deformation, and from my approach I can say how many flood cycle a dam can withstand before the failure. Now, why is this information so valuable? Because an engineer can collect the actual deformation data from the field and compare that with the predicted data from my model. Based on that comparison, decision on remedial measures can be taken to stop the upcoming failure. In last 20 years, North Carolina experienced 3 major storms: Hurricane Floyd, then Hurricane Matthew, and the latest one is Hurricane Florence. As the climate changes, these kind of catastrophic storms are becoming more frequent and stronger. But the budget allocated by the federal government to repair this high-risk dam is limited. My research will open the door for an engineer to assess real-time safety of the flood control earth structure and prioritize repair work. Thank you.